So let's try to do the same but with my numbers instead. So actually it's a bit of cheating to do it, since it's one thing to remember the steps and the values and one thing to like understand it. So really I should go back and do it again, and I will. Anyways, so with this, oops. Okay, now it's lagging because I'm rendering my movie, so I'm gonna use not this value and not this value. I'm gonna use my value. And also, I forgot one part which is extremely important, is that this has to be given. Oof, it lags. Okay, it doesn't matter. So okay, so what we do first is to calculate the ratio between the height, the length, and the width. So the thing is that because this L is the only variable, and this so it's this is L, this one before L, so obviously there. So Ly divided by Lx, just to remember, is 1.4. Cool. Also, apparently this was a value for some Eurocode, and I'm not sure if this actually is correct, but what you do is you take the longer values, so that would be 8.05 divided by 30, and 30 could be a given value, but could also be wrong. So that would be 8.05 divided by 30. So that means my slab is gonna be 2.6 meters high. This is my concrete slab here. This one. Yes. So I got me some water. Okay, tip, get a second computer with a good screen, so you can use a switch when you're rendering, so you can do it at the same time. So you don't get this lag. It's only when doing renderings. Doesn't matter. Okay, so that would be the height of my concrete slab. Zoom, 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 zoom. Okay, so that's the step one. Let's write it down to make mental notes. So thickness, then next, so the relation Ly Lx, and then we calculate the loads. Q. So here, I don't really know. Why shouldn't we also? No, probably not. Okay, so now we actually don't know. I assume also we should probably have some lead load, live load, but we don't. Probably not for this because we don't know the. I mean, it's for every building, right? But we don't know what type of building it is. So and that's given by code for 2 for a residential building, a normal house, I think, residential, and 5 for commercial. It depends on also the country, maybe. So 268. So we don't know that, but what we do know are these values. So 3.5 and 1. So the snow load, the dead load, and also we have to consider the concrete slab itself. So the finishing material, let's call it the finishing material, and plus concrete slab uses the dead load. The dead load coefficient, safety coefficient, which is 1.35, while the snow load and also the wind is actually divided in 2 parts, but we use 1.5 for that as well, combining the two. So there's one in suction, one in pressure, one in suction, or behind or below. And the snow load is 1.5, so we take 1.35 times 3.5 plus 1 times 1.5, which is 1.5. Also plus the height of the slab, 0.268 times the value for concrete, which is FCD, which is 25, which is given, times 1 times the length, right? But the which length? Should it be that length or that length? Oh, why should not? Pause. I am retarded. Obviously, it's this should make sense in my head before, but it didn't. Okay, so 1.35. This I knew, but okay. So my value for this would be 1.35 times. Okay, so okay, we do like 3.5 plus 1.5 plus 0.268 times 25 times 1.35. Ooh. This is all equal to 15.27. This would be my Q value. Cool. So next step, we're gonna. So it would depend. I'm gonna write it down like this. Loads MCX MCY from table. This is the next step. And this table, first we have to determine what kind of structure it is. So depending on what structure, depending on if there's fixed supports, which looks something like this, then we depending on which shape you will, or which side you will get different values. So, but in this case, there's only this will be fixed support, while if there will look just straight lines like this, or it will be simple support. And given where the placement is, you will get different values. So in this case, there are no fixed supports anyway, so they count all as simple supports, and that so we have this table here. And also here, remember the ratio we talked about before. So the ratio between Ly and Lx would be 1.4. Actually, when I used to think about it, that doesn't matter. That should be here. I mean, it doesn't matter. It just makes more logical sense, right, to put it there. So with that in mind, with that in mind, we should check as a 1.4, and then we see this one. This is the first one, which cool. So we get 1.4, so it's 7344. These values, and also wrote down divided by 100 because this is another unit. So 73 becomes 0.03 because we want to work in meters. So, and then we have this MCX, so 0.073 times the Q times the, let's see, so the length y squared. Get one value, and the value will be the same, and the y 2. I thought in my logic that it would be x here, x there, and in this value, but according to notes, no. So I assume the professors were correct than me, so I will continue doing this way. But I just assume the XX, YY, right? But no. Okay. And so for the first one, these values, well, it's gonna move it down to make it more like me. So MCX, that would be 0.073 times Q would be, so what did I say before? 15.2. 0.073 times 15.2 times the length, that was 5.75 squared. And you cannot see what I write here. Okay, so 0.073 times 15.2 times 5.75 squared. That's equal to 36.7. How could that? Okay, now I understand. This sucks a bit actually, but I understand because sometimes the numbers become same as your friends because their age is the same. which should be obvious, but okay. So with that, I actually remember how the other one. No, maybe I don't remember, but it doesn't really matter. 0.044 times 50.2, again the same thing, but 0.44 instead times 5.75 squared. I forgot a square there, but in calculation I did it. 0.44 times 45 times 5.75 squared is equal to 22.11, which is different than but why did he get the same? I didn't get the same. That's cool. So there was not the same numbers. I just thought, he got the same numbers in different. Okay, never. Doesn't really matter. Cool. So now that I have these values, let's try to think what I'm supposed to do. Okay, this I don't have a true understanding for, but you know, and that's not optimal, but I mean, it is what it is. So okay, so anyway, so now that I have these numbers, then we write them down. MCX 36.7 MCY. Now we know how much bracing I think we need in every place. So now we want to find out the width, like how many bars we're gonna have. So let's write this down. So what the fuck is happening? Cool. So with that in mind, so we're gonna number of bars and type. Actually, not type, but because we're gonna select a type or with a certain diameter, and then we're gonna use that. So actually, it's not type. Maybe now I understand why one of the values are a certain kind, because it's metal. And the metal has some kind of values. Cool. Okay, maybe I start to understand slightly more. Okay, so anyways, with this we have this US. Okay, I'm gonna. Okay, I tried to find my notes exactly because I normally write down well, but no, that didn't happen. So now we're gonna try USX and USY. So that would be actually this is. Sorry, US. This must be US Y. USX. So that is equal to the not MCY. The area times 28. 28 is a very random number which we don't know, and maybe change, but that's what we're gonna use. Remember, it's a strange number. Times. Yeah, this number. No, this is not USX. Oh. Okay, so this is not USX. I'm kidding. Okay, so we use so 36.7. It's a very low number. Okay, so now I remember. This is the second step. USX is equal to 36.7, which is MCX, which is row just above, divided by, now it's going to be a line there, so I don't want to do that, 0.9. Laggy. C, which is the thickness of the slab, minus 0.03. Let's divide. And also I think it's not this. Yeah, the keyboard is losing battery, so it's a bit slow. I remember it's not only about that. Okay, so I remember it was 0.2683, right? 268. Right? Okay. 268. So minus 0.03 is equal to 2.38, right? 0.238 times 0.9, poof. is equal to 36.7 divided by 0.2142 is equal to 36.7 divided by 9 is equal to 171.3 kilonewton. Cool. And what we do with that is now I know. So USX equals 171.3 times area of diameter that we don't know times this mystery number 28. Yes. So if we take 171.3 divided by 28, we get the area. So 171.3 divided by 28 is equal to 6.12. That's cool. This is the area of the diameter, right? So apparently we use between 8 to 20 millimeter thick bars, and in this example we're going to use 10, and this 10 diameter. So 10 diameters equal 5 radius, right? So the formula for the area of a circle is that. So that will give us pi times 0.5. Unit 0 strange. I just have to remember it's gonna be so it's a millimeter, right? So it's, yeah, that makes sense. So that would be 0.785. And if we take 6.12 divided by 0.785, 6.12 divided by ounce is equal to 7.79. That's the distance, so you add one extra, plus 1, so it'll be more or less 9, so you take 1 divided by 9, so 1 divided by 9 is equal to 0.11 meters. So that's the spacing behind. So obviously the extra one would be, you know, if this is 11 centimeters, this is one space, and that would be two bars, right? So that's why I add one extra, I assume, because here, you know, the amount of spacing. So that would be 3 spacing plus 1 bar. Cool. Every 11 centimeters. So that would be, my answer would be bars of 10 centimeters every 11 centimeters, or 0.11, a lot of meters. Pretty sure that's correct. Let's do the same for the y direction. Lag. Okay. So we got the value of 21. No, it's 22.11. Cool. Again. Oof. A bit painful. So, this is not this fault, it's the rendering at the same time fault. MCY is equal to 22.11. USY is equal to 22.11 divided by 0.9 times C, the thickness again, minus 0.03. So again, that's what we got before. I can do it again. So 0.268 minus 0.03. That's probably good. So times 0.9. So it's more or less 22.11 divided by 0.2142. 22.11 divided by answer is equal to 103.2. With that, 3. Well, that's 3. So with that, we know that USY times the area of the diameter times the Mach number 28 will give us, so if we write number 103.2 divided by 28 is equal to divided by 28, so that's 3.69. Looking nice, perfect level with the 6. And with that, we know that okay, let's see. Ooh, what do we do now? Okay, again, so that would be the area of this one, right? So with the formula of that's trying to be a pi, R2 again, with 8 to 20, we use 10 millimeters. So the radius divided by 2 to get this diameter, and divided by 2 give us the radius. 10 divided by 2 obviously is 5. 5 millimeters, so that would be 0.5, and so that will give us, you know, the same calculations again. We would take that, let's see, so more or less I can just write 3.69 divided by P times 0.52. That will give us, so 3.69 divided by, it's equal to 4.7. Again, 4.7, it will probably be the distance, that's how I would like to think about it right now, plus 1, that would be more or less, you know, every, so 6, this is trying to figure out how many per meter, right, how many bars per meter. So you give, so it's 4.7 distance, this per meter, right? So that would mean 1.6, 1 divided by 6, because you don't want to space them out, so, you know, you get, you mean 0.167 meters, so we get bars of 10 every 16.7 centimeters. Yay! This was actually nice.